All right, so here we go. We're going to go ahead and do some problems here with solving equations. And in particular, we're going to look at some unique situations that happen when you are solving equations. So let's just go ahead and do some problems here. Here's our first problem here. We have 7 times 2 and 7 times 5y. So what I'd like to first look at is just a quick review of solving equations. You have the left side and you have the right side. And before you can really start attacking the solving of the equation, you first need to simplify whatever's on the left side and whatever's on the right side. Make sure that both sides are simplified so that you can then start attacking the variable. So in this situation here, the easiest thing for us to do to simplify this is to use the distributive property. 7 times 2 is 14. And 7 times 5y is a positive 35y equals, and on the right-hand side, this side is already simplified. It's just 3y plus 14. 3y plus 14. So we have 14 plus 35y equals 3y plus 14. And from here, we go about trying to solve this equation for our variable y. In order to get the solution, we have to get all of our variable, which in this case is y, all of our y's on one side, and then all of our constants on the other. So for me, the easiest way to go about this would be to subtract 3y on this side to eliminate this, right? But whatever you do on one side of the equation, you have to do to the other side. So on this side, yeah, 3y minus 3y is 0y, or just 0. And 0 plus 14 is 14. So the 14 is just going to get brought down here. On the left side, we have 14 plus 35y minus 3y is 32y. So we have 14 plus 32y equals 14. So what we end up with here is an equation with all of our variables combined together, but we still have constants on both sides of the equation, and that's not what we're looking for. So let's get rid of this 14 because we don't want any constants on this side. Let's get rid of that 14. And we got to do the same thing to the other side. So we're taking away 14, we're taking away 14, and we're left with 32y equals 0. 14 minus 14 is nothing. We're almost to our variable. We almost have y all by itself. The last thing for us to do is to divide both sides by 32, okay? So let's divide both sides by 32. It's supposed to be a 3 right here. My mouse kind of freaked out. That gives us 1y equals 0 divided by 32. Anything with 0 divided by anything is 0. Now, the answer is 0. There is one solution, and the solution is y equals 0. That is the solution. It's a common mistake that we see with students and with people learning algebra at this point. When this happens, they go, oh, there's no solutions. And that is not true. There is a solution. It's 0. If I take 0 and plug it in here, and I take 0 and plug it in there, I get 14 equals 14. And that's a true statement. Y equals 0 is the one and only solution to this problem. Let's take a look at another problem over here on the right. So this is simplified, but the right-hand side, we can again use the distributive property to simplify. I'm just going to bring down the left-hand side. 36 minus 7p equals negative 7 times p is negative 7p. Negative 7 times negative 5 is positive 35. So we have 36 minus 7p equals negative 7p plus 35. Let's get all of our variables on one side. So let's get rid of this 7p. The inverse operation of minus 7p, or subtracting 7p, is to add 7p to both sides of the equation, which means this is going to cancel each other, right? We're left with 36 equals negative 7p plus 7p. That goes away, right? That cancels. That makes a 0p, which is just nothing. And the 35 gets brought down. So right now we have this equation that says 36 equals 35. Huh. That doesn't make much sense, does it? 36 does not equal 35. They are not equivalent. This is not a true statement. That is what I call a false statement. That's false. 36 does not equal 35. If I have a cash register and we're doing business here and I say, hey, your total is $36. If you give me 35, we're still one short. That is a false statement. They do not equal each other. And so when you end up with a false statement, this is what we call no solution. So there are no solutions to this equation. No solution. And what that means is that it does not matter what value you plug into this equation for p. You can plug in any number you want, no matter how large, how small, fractions, decimals, think of anything you want to think of. Nothing is going to make the left side of this equation equal to the right side of the equation. There is no solution. And so that's an example of when no solutions happen. You know the answer is no solution when you end up with a false statement, something that just simply is not true. Here, y equals 0, that's not a false statement, that's our solution. That's a single solution. So hopefully you're seeing a difference between the first problem and the second problem. There definitely is a difference. In the bottom left here, we have a similar kind of looking problem to the other ones. This side has already been simplified, but the left side, we can distribute the negative 4. We end up with negative 4v minus 12 equals negative 12 minus 4v. This side is already simplified, so we're just going to bring it down. And this side, we use the distributive property to simplify that expression. So we have ourselves nothing else we can do to simplify, but now we can start balancing the equation. And I like to usually go after my variables first. So if I have negative 4v, I'm going to do the inverse. I'm going to add 4v to both sides. And when we do so, negative 4v plus 4v is 0v. Same thing here. We're left with negative 12 equals negative 12. And negative 12 does equal negative 12. That is a true statement. Whenever you end up with variables disappearing and you have a true statement, whenever you have something on the left that is equivalent to something on the right, literally they're the exact same thing, that is a true statement. That is when you have what we call infinite solutions. Now, what that means is it does not matter what number you plug in for v. This side, the left side, will always be equivalent and equal to the right side. Plug in a negative number, a positive number, a big number, a small number, a fraction, a decimal, anything you want. If you plug in a number in for v, it will always be a true statement. All right, so these are 3 different examples here, one with a solution, and the solution is 0. And then we have 2 other problems, one with no solution and one with infinite solutions. So that's a real quick explanation of how this works. Later on, we get to learn about how you can have two solutions to an equation. And we'll keep learning as we get going into Algebra 2. You'll learn other stuff too. But right now, this is the meat of what you need to know. All right, guys, take care. Keep working hard. I'm out.